starting with solution of example. Let us revise those concepts which we have already discussed. If we know unit vector perpendicular to plane, that is normal to plane, and perpendicular distance of plane from origin, then we can write equation of plane in vector form. Suppose n cap, it is a unit vector which is normal to the plane, and perpendicular distance of plane from origin p. Then equation of plane in vector form, r bar dot n cap equal to p. If we know direction cosines of normal to the plane and perpendicular distance of plane from origin, then we can write equation of plane in Cartesian form. Suppose L, M, N, they are direction cosines of normal to the plane. Now direction ratios or direction cosines, they are for a line or vector. For a plane, there cannot be direction ratios or direction cosines. And a line or vector which is perpendicular to plane, it is normal to the plane. So here L, M, N, they are direction cosines of normal to the plane, and P, perpendicular distance of plane from origin. Then equation of plane in Cartesian form, Lx plus My plus Nz equal to P. Instead of direction cosines, if we know direction ratios of normal to the plane, suppose A, B, C, they are direction ratios of normal to the plane. Then equation of plane in Cartesian form, Ax plus By plus Cz plus D is equal to 0. Here A, B, C, D, they are the real numbers, scalar quantities. If we know position vector of any one point in the plane and vector normal to the plane, then also we can write equation of plane in vector form. Suppose A is point in the plane with position vector A bar, and N bar is a vector which is normal to the plane. Then equation of plane in vector form, R bar dot N bar equal to A bar dot N bar. Dot product of two vectors is a scalar quantity. So same equation can be written, R bar dot N bar equal to D. Instead of that, if we know coordinates of any one point in the plane and direction ratios of normal to the plane, then also we can write equation of plane. But that equation, it is in Cartesian form. Suppose direction ratios of normal to the plane A, B, C, and coordinates of one point in the plane x1, y1 z1. Then equation of plane in Cartesian form, x minus x1 into a plus y minus y1 into b plus z minus z1 into c is equal to 0. Instead of direction ratios of normal, if we know direction cosines of normal and coordinates of one point in the plane. So direction cosines of normal LMN, coordinates of one point in the plane x1, y1, z1. Then also we can write the equation of plane in Cartesian form, x minus x1 into n plus y minus y1 into m plus z minus z1 into n is equal to 0. If we know position vector of any one point in the plane and two vectors parallel to the plane, then also we can write the equation of plane. Suppose A is point in the plane whose position vector A bar. Vectors parallel to the plane B bar and C bar. Then equation of plane in vector form, R bar dot B bar cross C bar equal to A bar dot B bar cross C bar. Now here we can observe that on LHS as well as RHS, three vectors are there, and among three vectors dot and cross product is there. So same can be written in the form of box product. In box, R bar, B bar, C bar is equal to in box A bar, B bar, C bar. So scalar triple product can be expressed as box product. Now these equations, they are in vector form. Now equation of plane can be written in vector form, but that is another form, that is parametric form. So position vector of one point in the plane A bar, B bar and C bar, they are parallel to the plane. Then equation of plane in vector form can be written R bar equal to A bar plus lambda B bar plus mu C bar. Here lambda and mu, they are scalar quantities. They are also known as parameters. Now this equation of plane, it is also in vector form, but here lambda and mu, they are scalar quantities, parameters. So this equation, it is in parametric form. These equations, they are also in parametric form. They are also in vector form, but parameters are absent. So these equations, they are in non-parametric form. If we know position vectors of any 3 points in a plane, then also we can write equation of plane in vector form. Suppose A, B, C are the 3 points in the plane with position vectors A bar, B bar and C bar. Then equation of plane can be written in vector form, R bar minus A bar dot in another bracket A bar cross B bar plus B bar cross C bar plus C bar cross A bar equal to 0. instead of knowing position vectors of 3 points in a plane, if we know coordinates of any 3 points, suppose A, B, C are 3 points, coordinates of A, x1, y1, z1, B, x2, y2, z2, point C, x3, y3, z2. Then we can write equation of plane in Cartesian form. Indeterminate. X minus x1, y minus y1, z minus z1. Second row. x2 minus x1, y2 minus y1, z2 minus z1. Third row. x3 minus x1, y3 minus y1, z3 minus z1, and this is equal to 0. Equation does not contain vector quantities, but equation contains determinant. Observe elements of second row. x2 minus x1, y2 minus y1, z2 minus z1. So difference between corresponding coordinates of 2 points A and B. It means that in second row of determinant, what we get is direction ratios of AB. Consider elements in third row. x3 minus x1, y3 minus y1, z3 minus z1. So they are direction ratios of line passing through points AC, or direction ratios of vector AC bar. Find the vector equation of plane passing through a point having position vector 3i minus 2j plus k and perpendicular to vector 4i plus 3j plus 2k. So in this example, position vector of one point in the plane is given. Suppose it is point A with position vector A bar. So here A bar equal to 3i minus 2j plus k and perpendicular to vector. Plane is perpendicular to vector. It means that given vector, it is perpendicular to the plane, and vector perpendicular to plane is known as normal to the plane. So usually normal vector to plane is denoted by n bar. So n bar equal to 4i plus 3j plus 2. So position vector of one point in the plane is given, vector normal to the plane is given, and we have to write equation of vector in vector equation of plane in vector form. So equation of plane in vector form is given by r bar dot n bar equal to a bar dot n bar. Put the corresponding values. R bar dot n bar in bracket 4 I cap plus 3 j cap plus 2 k cap equal to, on right hand side, dot product of two vectors. In first bracket 3i minus 2j plus k dot, in another bracket 4i plus 3j plus 2k. Dot product of two vectors is a scalar quantity. So dot product it is also known as scalar product. Now here both the vectors, they are expressed in terms of unit vectors ij. To find their dot product, we have to find product of coefficients of ij. Product of coefficients of I, 3 into 4, plus product of coefficients of j, minus 2 into 3, plus product of coefficients of k, 1 into 12 minus 6 plus 14 minus 6, 8. So equation of plane in vector form, r bar dot 4i plus 3j plus 2k equal to 8. In the example, if it is not mentioned, only find equation of plane, then we have to find equation of plane in Cartesian form as well as vector form. Here it is mentioned that we have to find equation of plane in vector form. Therefore, we need not find equation of plane in Cartesian form. But if we have to find equation of plane in Cartesian form, then vector form can be converted into Cartesian form. Suppose point R, whose coordinates x, y, z. Position vector of a point, it is vector directed from origin towards that point. Usually position vector of point denoted by small letter r bar. Coordinates of point, they become coefficients of unit vectors ij. So we get r bar equal to xi plus yj plus z. Put this value here in one bracket, xi plus yj plus z dot in another bracket, 4i plus 3j plus 2k equal to 8. On LHS, dot product of two vector quantities and dot product of two vectors scalar quantity. Find sum of product of coefficients of ij. X into 4, 4x plus 3y plus 2z equal to 8. This is equation of plane in Cartesian form. So equation of plane from vector form can be converted into Cartesian form. Cartesian form can be converted into vector form.
Welcome to Sanjeevani Education Group. Sanjeevani Education Group is a IIT NEET coaching hub which is renowned for producing the rankers in different competitive exams from national level 11th and 12th JEE NEET, Standard 10 NTSC MTSC, 6th and 9 Dr. Homi Bhabha Bal Vaidyanik exam, 5th and 8th scholarship exam, 7th Olympiads along with IIT NEET Foundation for all classes. We have experienced faculty who focus on the academic development of students. So dear parents, hurry up. For admission, visit Sanjeevani Education Group, plot number 13, Aditya Nagar, Gadkheda, Aurangabad, or call 95112 70135 or 95112 66680.